another video. Ba? Sure ba?
New video na lang.
Welcome to our video. So today we are going to discuss about a voltage divider transistor amplifier. It is considered as a Class A amplifier since our circuit looks like this. So before we start solving, we are going to discuss first the parts of our circuit. So we have here the coupling capacitors, which is the C1 and then C2, which is the input and output coupling capacitor respectively, and the bypass capacitor C3, which bypasses the effect of RE, or the resistor in our emitter side, for easier computations. So this is the voltage divider will be here. There's two resistors in the base part. We all know the base part or the parts of our transistor: the collector, the emitter, and the base, in which there are two resistors dividing for the current. That's why it's called voltage divider. Then the RC, or the collector, or the resistor at the collector side, and the RE, which is the resistor at the emitter side. We have an RL, which is connected in parallel with our RC. RL stands for resistor at the load side because this is a common emitter amplifier in which the input voltage will be from the base, then the output will be taken to the collector side. So proceeding. Anyway, we are going to solve for the DC analysis, in which we will get the R prime E in order to solve for the gate.
So now, we will use the exact method. To solve for IE, we will use a Thevenized circuit. So VTH minus the voltage of RTH minus VBE, which is constant 0.7, minus the voltage of RD, and equals to 0. So now we will use the two formulas. The VTH is equal to VCC minus R2 all over R1 plus R2, and RTH is equal to R1 parallel to R2. So now, with the given example, we will now solve the VTH and RTH. So VTH is equal to VCC, which is 20 volts, times R2, which is 4.7K, all over R1 plus R2, which is 47K, and 4.7K ohms. Equal to 20 over 11. So now we will solve for RTH. RTH is equal to R1 parallel to R2. R1, which is 47K ohms, parallel to R2, which is 4.7K ohms. Which is equal to 47,000 over 11 ohms.
From the Thevenized circuit that we had, and the relationship between the IB and IE, which is derived from these formulas, IE is equal to IC plus IB, and beta is equal to IC over IB, we will come up to this formula, which is IE is equals to VTH minus the VBE, which is 0.7 over RTH over beta plus 1 plus RE. We need to solve for IE. In order for us to solve for the R prime E, R prime E is the internal resistance of the emitter side caused by the beta. And now, let us solve for the IE. IE is equals to VTH minus 0.7. So, by substituting it, VTH is equal to 20 over 11 minus VBE, which is 0.7 over RTH over beta plus 1. RTH is equals to 47,000 over 11 over beta plus 1. Beta is equal to 150 plus 1. Then plus RE, which is equal to 10,000. Therefore, the IE is equal to 78.3434 microampere. Now that we have already an IE, we can now solve for the R prime E using the formula 26 millivolts over IE. So by substituting it, R prime E is equal to 26 millivolts over IE, which is 78.3434 microampere. Therefore, our R prime E is equal to 331.8699 ohms.
Before proceeding in solving the voltage gain, we shall draw first the AC equivalent circuit using the simplified R parameter. Always remember that in AC analysis, the capacitors are shorted and the BCC is grounded. So, from the input voltage, C1 is shorted. Since R1 is connected to VCC where VCC is grounded, so R1 is connected to the ground, as well as R2, which is in parallel with R1. Then, let us draw the simplified R parameter circuit of this BJT. As you can see, RE is not included in our circuit because in AC analysis, when the resistor is in parallel with the capacitor, the current flowing through that resistor is equals to 0. So, RE is negligible. Proceeding, the RC is in series with the current source. C3 is shorted. Then RL is in parallel with the RC. Then the voltage out. Our AC equivalent circuit is done.
From the AC equivalent circuit, we can easily see the input and the output side. The voltage gain is equal to negative RC parallel to RL all over R prime E. The gain is negative because the configuration of our amplifier is a common emitter, which inverts the output signal. Using this formula, resistance value at the output and the denominator is the input value of our circuit. Using substitution, we can solve now for voltage gain. Negative RC or 1 kilo ohms parallel to RL or the value of 500 ohms is equal to R prime E with the value of 331.8699 ohms is equal to negative 1.5066. Now we have the voltage gain. We will use this value for the high frequency response, which will not be included in this video. Thanks guys, I hope you've learned something from our video. Peace!